Hey guys, Mrs. Hyjic here with your Ptcr Objective 2 video. Please make sure you've set up your Wix. Our objective today is to understand that the periodic table is an organizational tool that can be used for the classification of elements, as well as identifying and predicting properties and patterns of elements. We have 5 essential questions, so let's begin. But first, let's talk about where the periodic table came from. It was actually developed back in 1869 by a German scientist, the name Dmitri Mendeleev. And he was studying all of the elements of the time, and he organized a chart based on the way that those elements looked and the way that they reacted, or their chemical behavior. Later on, the periodic table was reorganized according to the unique atomic number. Surprisingly so, very few elements were shifted out of their original location where Mendeleev had put them. So today's periodic table is based on an increasing number of protons, or the atomic number of the individual elements. There are some trends on the periodic table that you need to be familiar with. First of all, what do the atoms in the same row have in common? Well, the rows are called periods. So on the periodic table, there are 7 periods, or 7 rows. Now, let's take a look at this first row for period 1 and ask ourselves, what do the 2 elements, hydrogen here, and then we jump over to helium, there's only 2 atoms or 2 elements in the first row. What do these atoms have in common? Well, I hope you see that they only have one energy level that makes up their atom. So they're very small. Period 2. What do all of the elements in period 2 have in common? We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Well, all of these elements, all of these atoms that make up the elements in period 2 have 2 energy levels that make up their atoms, so they're a little bit bigger in size. Here's period 3. Sodium, magnesium, aluminum, over to argon. Well, these atoms in period 3 have 3 energy levels. So one of the trends you need to be familiar with is that the period number determines how many energy levels an atom of those elements have. So if I was looking at an atom or an element on the periodic table and it was in period 6, how many energy levels would an atom in that period have? 6. And so it's a really easy way to figure out the number of energy levels that your atom is going to have by looking at its location on the periodic table. What period or row is it in? Now, what do atoms in the same column? The columns are called groups or families. What do they have in common? The columns have in common. Well, here's a column. This is a group or family. It's group number 1. Here's a column. It's group number 2. And then we jump over to column number 13, 14, 15, 16, 17, and 18. There are 18 columns or families on the periodic table. So let's ask ourselves, what do the atoms or the elements in these columns, these families or groups, have in common? Well, hydrogen, lithium, and sodium are all in family number 1. Well, hydrogen has 1 energy level, lithium has 2, sodium has 3 because they're in different periods. But look at hydrogen. Hydrogen has 1 electron in its outer shell, which for hydrogen is the first one. Lithium also has 1 electron in its outer shell. And sodium also has 1 electron in its outer shell. Do you remember what those electrons in the outer shell are called? They have a name. Valence. Valence electrons. All right, valence electrons. Good job, guys. So all of the atoms in family or group number 1 have 1 valence electron. Take a look at family 2. Beryllium has 2 valence electrons. Magnesium has 2 valence electrons. They're in family group number 2. They have 2 valence electrons. And then we jump over to group 13. Boron has 3 valence electrons. Aluminum has 3 valence electrons. Group 13, drop the 1, has 3 valence electrons. So how many electrons does group 14 have? Drop the 1. 4. Carbon has 4 valence electrons. And so does silicon. 4 valence electrons. How about group 15? Nitrogen and phosphorus. How many valence electrons does nitrogen and phosphorus have in group 15? Drop the 1. They have 5 valence electrons. Group 16 has 6, 17 has 7, and group 18 has 8. For the exception of helium, since helium is in period 1 and only has 1 energy level, which is considered full with 2 electrons, helium only has 2 electrons in its valence shell. Neon and argon and all of the other elements in group 18 have 8 valence electrons in their outer shell. They're in group 18, 8 valence electrons. Helium is the exception though. Helium is actually here with group 18 instead of over here with group number 2 because its energy level is full. The first energy level is considered full with 2. All of the other energy levels are considered full at 8. So helium has a full outer energy level. In this case, it's 1 energy level. It's full. So it belongs over here with group 18 because it actually behaves more like all of the other atoms in group 18 because it has a full energy level. So, 2 very important trends. All of the atoms in the same period have the same number of energy levels. All of the atoms in the same group or family have the same number of valence electrons. So again, valence electrons are the electrons that are found in the last or outermost energy level. And as we've already mentioned, atoms in the same family or group, that's the columns on the periodic table, have the same number of valence electrons. Now the number of valence electrons will determine an atom's chemical properties. So if I have the same number of valence electrons, I'm going to have similar chemical properties. So oxygen here, 1, 2, 3, 4, 5, 6, has 6 valence electrons. Neon, 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. On the periodic table, oxygen would be in group 16. Neon would be in group 18 because, again, the group determines will tell you the number of valence electrons. And all of the atoms in group 1 that have 1 valence electron, they're going to have similar chemical properties. And all of the elements in group 2 have 2 valence electrons, and they're going to have chemical similar properties. And all of the elements in group 13 have 3 valence electrons, so they're going to have similar chemical properties. So, you need to be familiar with the trend of energy level number, valence electron number, and how the number of valence electrons determine the chemical properties. So if I have the same number of valence electron, I'm in the same family, I have similar chemical properties. Alright, so when it comes to the organization of the periodic table, metals are found on the left-hand side of the periodic table. There's a stair step that goes right through here, which divides the left from the right. The left side will be where you find your metals. The exception is hydrogen. Hydrogen is a gas. It's a nonmetal, but it's found over here on the metal side because it has 1 valence electron. It behaves more alike all of the other elements in group number 1. So even though it's a nonmetal, it's here on the periodic table because of its 1 valence electron. The physical properties of metal is that they are malleable, meaning they can be flattened and shaped, ductile, which means that the metal can be drawn into wires, and they're really good conductors of heat and electricity. The chemical properties that you need to be familiar with our metals really is just this first group right here, group 1. The name of group 1 are the alkali metals. And what you need to know is that the alkali metals are the most reactive elements on the entire periodic table. And the reason they're so reactive is because they have so few valence electrons. That 1 electron in their outer energy level makes them extremely reactive. So the alkali metals, the left-hand side are the metals, the first column on the metal side, column 1, family 1. The alkali metals are the most reactive, and the reason they're so reactive is they're 1 single valence electron in their outer shell. On the right-hand side of the stair step, we're going to find our nonmetals. So our green ones over here are nonmetals. They're on the right side of that stair step. The physical properties of nonmetals is that they are brittle, which means they're easily breakable. They're dull, and they're very poor conductors of heat and electricity. Now, when it comes to chemical properties, we need to be familiar with a nonmetal group, and that's group 18. Group 18 is called the noble gases. And remember, we mentioned just a few minutes ago that all of the elements in group 18 have a full outer energy level. Helium is full with 2, and the rest are full with 8. So they have a full outer energy level. Because they have so many valence electrons, the noble gases are considered stable. They're not reactive at all. So the alkalis are the most reactive. The noble gases are not reactive at all. And then right along the stair step is our third category of elements on the periodic table. Those are the metalloids. The exception to the metalloids is aluminum. Aluminum is on the stair step, but it's actually a metal. And astatine, which is on the stair step, but it's actually a nonmetal. The physical properties of the metalloids is really that they have properties of both metals and nonmetals. Chemically speaking, they behave more like a nonmetal would behave. So your support item for this video is to actually watch a video. We'll be watching this video in class, and then you will be describing the physical and chemical properties of cesium based on its location on the periodic table. So before we watch the video, I guess all you can do is take a look at your periodic table and find cesium, because we're going to be talking about the reactivity of cesium. All right, guys, I'm out.